Hi guys, my name is Aaliyah Mahabir, and I'm going into my second year of chemistry here at Carleton. Today you're going to be seeing some videos for the Chem 1000 lab. These videos are to give you an idea of how to do the labs, different techniques you can use, and different procedures involved in the lab. They're just to help you see what you're supposed to be doing and maybe to help you improve on your lab techniques so you'll get better results. The labs we're going to be looking at are the Redox Titration lab, the Synthesis of Salicylic Acid lab, the Chemical Kinetics lab, and the Ion Exchange Chromatography lab. If, after watching these videos, you're still unsure about some things or have some questions, don't hesitate to go and see your TAs. They're more than happy to help you, and that's what they're there for. So we're going to start with step 5, assuming that steps 1 to 4 have been done already. So we first have to check our initial reading of our KMNO4. So in my case, I have an initial reading of 3.2 mils. So then in step 5, I'm going to add 250 milliliters of 1 molar sulfuric acid that we made in step 2 to our sodium oxalate here. And we'll swirl the solution until it dissolves. And if there are any big chunks of sodium oxalate, you can crush them with a glass stirring rod so they'll dissolve. So just to recap step 5, we added our 250 milliliters of 1 molar sulfuric acid to our sodium oxalate and swirled it or stirred it with a glass stirring rod until all of it was dissolved. In step 6, we're going to titrate our solution with our KMNO4. And we can quickly add our 90% consumption. In my case, it will be about 30 milliliters, but your calculation will be done in your pre-lab. And then once you add your 90% consumption of KMNO4, you can swirl your solution until it becomes colorless again. So in step 6, we added KMNO4 to our 90% consumption, and then we swirled it until the solution became colorless again. In step 7, we're going to heat up our solution to about 55 or 60 degrees. and then we'll complete our titration going drop by drop until the solution becomes pale pink in color. All right, so we're at 58 degrees, so we can continue our titration drop by drop until our solution turns pale pink in color. It might be easier to see the pink color if you put a small white piece of paper or a Kleenex underneath your beaker. So once you get a pink color like this, swirl it for about 30 seconds to make sure the color persists. If the color goes away, add another drop, then swirl for 30 seconds. So once you've reached this color, record your final endpoint. So for step 8, you'll take your 250 milliliters left from your 1 molar sulfuric acid solution and use it to correct your endpoint by titrating it with 1 drop of your KMNO4, and it should change color after the 1 drop. And so it's a very pale pink, so you know that your titration was correct. So just to recap, we took our leftover 1 molar sulfuric acid and titrated it with 1 drop of our potassium permanganate in the burette, and just observed that it did in fact change color, so we can correct our endpoint to adjust for that. And the rest of your lab is to titrate your iron ore, and you're going to follow exactly the same procedure as you did for this, except with your second sample. And don't forget to record your initial point and your end point.